We're going to look at a situation using forensic photogrammetry, how to take a picture and figure out some, drug kingpin's house, and it was proof that the hit on, Vinny the Ice Pick was done. And the police don't know the time it was taken, but they know it was taken on September 12th, 2020 in Boulder, Colorado. So, what evidence can you use in the picture to find the exact time of day this murder was taken? Because you know that the hitman took a photo to prove he'd done it. So, this should be contemporaneous with the time of the shooting. So, what we have to do is start thinking what information is in this picture that we can use to find the time of day. And it's pretty obvious it's the shadow from the sun. So I did this earlier and I've undone all my work and I'm going to redo it now so you're not spending 45 minutes with me as I draw. We don't have any scale on these pictures, unfortunately. So if I draw the height of the tree here and then I draw the length of the shadow down here, all we need to know is those two sides. But we have no means of measuring it. A lot of software programs will allow you to measure distance, but not this one. But there's a trick around that. I draw a square and I start duplicating my square. And I clear it out and I've got a ruler. And to double it up again, join it, and I got myself a lovely ruler I've just made to get my values. I don't need real life values. I'm only after a ratio, okay? Make 2 copies of the ruler and I count the sides. And what I wind up getting is we've got a triangle that's 20 units high, 25 long. Okay? Now, if we had a large protractor, we could have laid that on and done the angle itself directly from the tree tip to the shadow's tree tip. But we don't. So we've got our scale now. In real life, we could have just laid a ruler on the picture. So this is what we've got. I'm extending this hypotenuse vector just so you understand. It's pointing at the sun, and that's our key here. We need to know the position of the sun because that's our time of day, how high the sun is above the horizon. We're making some basic assumptions here. We don't know which way is north or whatever, so we're assuming that this is like to the left of the picture is facing east. We want to keep our first forensic photogrammetry example simple. So what is it we're after here? We want that angle theta from the information, and we have enough to get it. Keeping it simple, without getting too fancy with my math layout, the tangent is 20 over 25. Don't do that in your calculator. Reduce a fraction if you see it. That's the actual number you're going to put in your calculator. Okay? Now, it's very easy to do this. 0.8, 0.14 degrees. Wait a minute. Oh, wait a minute. I didn't do inverse tan, 38 degrees. Really common thing that you could do is 0.8, hit inverse and hit cos by mistake. Get the same answer. 0.8 inverse, hit tan h, a different function. Okay, you get 1.09. Inverse, accidentally hit this key. You get 0.512. So it's very easy to get wrong angles on this, but seriously, this triangle is nearly 1-to-1. The answer should be around 45 degrees. The other one that can happen to you is this. 0.8, but you left your calculator in radian mode and you hit inverse and you get 0.67. So formulas don't have brains, you do. This triangle should be very close to 45 degrees. So the tan inverse is roughly 39 degrees. Okay? What are we going to do now? We need to take this angle and go to the NOAA calculator, which I have here, and we're going to see what happened on September 12th in the year 2020 in Boulder, Colorado. Well, at noon, or roughly noon right now, the sun is at 53 degrees on September 12th, 2020. So let's just roll this back a bit. We'll take it right to 11 o'clock. It's at 51. So let's go to 9 o'clock. The sun's elevation is 36. Hey, we're getting close. 9:15. The sun's elevation is 38.56. And I forget what our calculator said. I closed it. We're roughly 39 degrees. So it looks like it's 9:15. How crazy close do we want to get? What if I do 9:10? 37.76, 9:20, 39. So it's between 9:10 and 9:20. So we've got 9:15 a.m. according to NOAA. So this guy was shot at 9:15 a.m. using trigonometry to do a little what's called photogrammetry. Now, obviously, one of the most important other things to do would be to know the angle back and forth this way. So if you could go to the park, you might have to correct for the tree shadow and the direct facing east and west, but that gets really complicated. And it's just more trig, but it's done on the horizontal, it's done on the vertical, east, west, north, south, up, down. But as a simple basis, we can pretty much conclude it was 9:15 in the morning, according to this picture. And this is why it's so easy for intelligent police to catch you.